Hi, what's up people? Mr. Highway here. We have come to the last question in 2020 O-Level A-Maths Paper 2 Analysis. So this question, I didn't do that well, so I scored some correctly, but some I didn't do it correctly. So we're going to start on a clean slate and see how I do it correctly this time around. Okay, part 1. The diagram shows a vertical cross-section of a container in the form of a cone, height 25 cm and base radius 15 cm. The container is initially empty. At time equals to 0, liquid is allowed to flow in through a small hole close to the vertex. Now, the shape is like this, right? Water is flowing in from the vertex. That means it's coming up from the top where the pointed part is. Okay? And the water level, therefore, is rising from the bottom up. After t seconds, the height of the liquid of the container is 25 minus x, and the volume of the liquid is v cm. Show that v is equals to 3 pi times 625 minus x cubed over 25. Okay, I didn't get this part right. So let's try again. Now, v is in fact the volume of the liquid, right? So that means you have the big cone minus the small cone. That will give you the volume of the liquid here. The big cone will be 1/3 pi r square height. The height is 25, the r is 15. Okay, minus the small cone, which is 1/3 pi r square. Now, what this r is, we are not so sure. It's not directly available to us. The height here is x though. So typically for this kind of questions, you're going to do a bit of congruence and similarity to find this r using similarity. So over here, I'll write this r over 15 is equals to the small one, small height, which is x, over 25. Divided by 5 is 3, divided by 5 is 5. So we have x, right? We don't have r, so we make r the subject. R is equals to 3x over 5. Alright, so that's the r square height. Okay, so if I expand and simplify, I should be able to get this. But I'm going to factor out 3 pi, isn't it? Which is what I'll do. So I factor out 3 pi. The 1/3, I already have 1/3. If I factor out another 3, I'll get 1 over 9. 15 squared is 225. And then we have 25 here, okay? Minus 1/3 pi, the pi goes out. 1/3 then divided by 3 again, you get 19. And here we have 3x squared is 9x squared over 5 squared is 25. Then we multiply by another x. Okay, so far everything looks good. I just need to press calculator for this. So we have 2 to 5 times 25 divided by 9 is 625. Very nice. So that I got it. This is 3 pi times 625 minus x cubed over 25. Okay, that's it. What happened? I couldn't do this on that day. So let's look at my working that day, right? I tried to be funny. I tried to do a volume ratio thing, which is volume of liquid is equals to volume of cone minus volume of space. Later on, I revisited this method that I used here during the exam, and I found out that it actually works. It's just that I messed it up. The first thing I did was to calculate the volume of the cone. The dimensions are all given, so I just sub them in to the formula, and I got 1875 pi. Next, we look at the length ratio between this empty space here, the small cone, and the big cone, which is the entire thing. The length ratio would have been this height here, which is x, over this entire height here, which is 25. So we have x over 25, the length ratio. That's correct. The volume ratio then would be the cube of this length ratio, isn't it? So that's where my mistake was. It should have been x over 25 cubed, but somehow I'm going to do a 5 cube over here. Yeah, I know, that was dumb. You can see I wrote over here, my concentration was dropping, right? And yeah, I messed it up. So then if we have 25 cubed, this should have been x cubed over 15625. The volume of the liquid, which is what we want to find, is equals to the volume of the cone minus volume of space. The volume of the space would have been this ratio times the original, isn't it? So instead of 125, this should be 15625. X cubed over 15625 times 1875. And that would give us 3x cubed over 25. So now we can put it here where the volume of liquid is equals to the volume of the cone minus the volume of the space. Volume of cone is 1875 pi. The volume of the space, I'll just write it in here, 1875 pi times x cubed over 15625. So if you cancel this, like I said earlier on, it will be 3 over 25. We will factor out 3 pi as a common factor. So now I'll write the next line of working here. We will factor out 3 pi. 3 times 625 is 1875, so that's correct. This is correct. And if I factor out 3 pi, so pi is here, 3 is here, we will have x cubed over 25. And that's correct as well. Exactly what the question was looking for. I should just go for the direct approach. I tried to use a different method that in the end didn't work out so well. So I was like, heck, I'm just going to skip. I'm just going to take this result and go to the next part. Because I told myself that this is 3 marks. So if I just do this much already, maybe I'll get 1. Then I just skip to the next part using the result that was given. Okay, this show result. Yeah. Okay, so let's go to part 2. Given that the rate of flow of the liquid is kx squared cm cubed, where k is a constant, find the expression for dt dx in terms of pi and k. An expression for dt dx. So the first thing that comes to my mind is the chain rule equation. dt dx is equals to dt times something dx, right? So dt, well, what's that? It's dv, right? dt v dv, dv dx. So this is my usual approach. I will split the dt dx into dt here and dx there. And I must have the other variable here and here, isn't it? And there's nothing else except volume. So it must fit in. Then we do a quick check. The dv will cancel, we get back dt dx. Okay, that's good. So let's see what are the information that can fit in. dv dx, we can just differentiate this. The rate of flow of the liquid is kx squared cm cubed per second. That's the v dt, but 1 over that, right? So dt dv is in fact 1 over dv dt. So I'll just write it here. dt by dv is equals to 1 over dv by dt. Yeah. So that's actually 1 over kx squared cm cubed per second. Let's jump to the v and let's do a dv dx. You differentiate the 625 is gone, right? In fact, we differentiate the 3 pi times 625 is gone. We differentiate what's in here, you get negative 3x squared over 25. So we multiply this to, we have negative 9 pi x squared over 25. Okay, so let's fit them in here. Then we can find dt by dx to be equal to 1 over kx squared times negative 9 pi x squared over 25. Okay, the x squared cancels off, so dt dx is equals to negative 9 pi over 25k. Okay, that's it. So yes, I got this correct in my attempt. Now let's go to part 3. Part 3, the liquid was allowed to flow for 72 pi seconds when the height of the liquid reached 12 cm. By expressing t as a function of x, find the value of k. Okay, this is a really sneaky question. There's quite a few details I missed and we'll see what they are. This is a continuation from the previous part, where we saw that dt dx is equals to negative 9 pi over 25k. So we write that down, dt by dx equals to negative 9 pi over 25k. The first thing that I missed was this. It says here by expressing t as a function of x, that means you have to find t in terms of x, which means we integrate both sides from here. So we have integrate dt dx. We are integrating both sides with respect to x. Would be equals to integrate negative 9 pi over 25k dx. So now, if you don't already know, the integration with respect to x cancels this dx. Okay, it works that way. And so you have a t. On the right hand side, we have negative 9 pi over 25k x plus c. T is going to be a function of x, so we're doing an indefinite integral, which means we have to find the value of c, right? So we, of course, as usual, we need to sub in values of t and x to find the value of c, but where do we get that? This one is one possible one. Okay, we need one to sub in to find the value of c, and then another one to find the value of k, okay, as you will see in a while's time. So this is one pair. Another one will be at the beginning of the question, which is this one. The container is initially empty, which means that when t equals to 0, x equals to 0. I wrote it down, but then I think in the end I didn't use it in the question, and so I didn't do it correctly. Now here's the twist. In fact, this is also wrong. Okay, what I wrote here was wrong as well, because I missed something there, and it's what x actually means. Now, one more time. The water is dripping this way in, drip, 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 and the water level rises up from bottom up, right? Okay, now, if you didn't read it carefully, or you don't remember it correctly, you think that x is the water level here, but actually it is not. X is the length of the empty space over here. Wow, that was sneaky, man, that was sneaky. And I missed it. Okay, I read it, but I wasn't kind of alert to it and raised a red flag right in the beginning because I should have seen it. If I were to get it right, I would have seen it right the first time I read it. Okay, I know that, okay, this is something you have to be careful about. It's counterintuitive. X is not the water level, but x is in fact height of the empty space on top of the water level. Wow. So to correct this, when initially, that means time equals to 0, we have no water there. So the height of the empty space is in fact 25 cm. Okay, so the correction should be when t equals to 0, x is equals to 25. That's the correct version. So let's apply it here. When t is equals to 0, x is equals to 25. So 0 is equals to negative 9 pi over 25k times 25 plus c, and so c is equals to, this 25 cancels, then you bring this over, you have 9 pi over k. Yup, c is equals to 9 pi over k. And we write the entire equation down, we see that t is then equals to negative 9 pi over 25k x plus 9 pi over k. So only when we get this do we sub in this value here, 72 pi and 12 cm. Okay, the height of the liquid is 12, but again x is not 12, x is 25 minus 12, which is equals to 13 cm. Okay, so we sub that in, sub x equals to 13, t equals to 72 pi. 72 pi is equals to negative 9 pi over 25k. X is 13 plus 9 pi over k. Alright, so we divide throughout by pi. We have a cancellation here. Divide throughout by 9. We get an 8 here. Multiply throughout by k. We have a k here, we'll cancel this k, cancel this k. Divide by 8, that's what k is. K is 1/8 of negative 13 over 25 plus, everything got cancelled off here, so you got 1 here. Okay, we press the calculator, we get 3 over 50. That's the correct answer. This was the working that I did for the initial time when I actually tried the exam paper. I wrote it there, there's 33 minutes left. I squandered all of the 33 minutes on question 9 and I couldn't get it right. Okay, so that was a big mistake that I made in this exam paper. The other thing is x being the height of the empty space in this question, I missed that. The best way to get this right is in fact to recognize that this is a potential error, because intuitively we would think that the height of the water level is x, but in fact x is the height of the empty space. Another mistake was that instead of expressing t as a function of x, which is required in this question, I went to do a definite integral from 0 to 72 pi. I haven't completely figured it out, but in the end I couldn't get a correct answer. Maybe it could have worked, I don't know. But anyway, it doesn't meet the requirements set out in the question. So that shouldn't be the way to do it as well. Oh yeah, I saw this. By the time I reached here, my concentration was dropping, so I took a 1 minute nap and I felt much better. So that's a strategy that you might want to use if you have quite a lot of time that's left behind, which is actually the case for me. So yeah, I can spend 1 minute for a nap, no problem. Alright, so that was the 11 questions in this paper. I'll do one more video to summarize everything, look at how I could have done this better on the overall strategy. Like and subscribe, see you next time.